Okay, solving a system of equations using the inverse of a matrix. Given a system of equations, write the coefficient matrix A, the variable matrix X, and the constant matrix B. Then AX is equal to B. And then we're going to multiply both sides by the inverse of A to obtain the solution. So if we multiply both sides by A inverse times A is the identity matrix times X, which is equal to A inverse times B. And the identity times X is X, which is equal to A inverse times B. Now, the question answer here is that if the coefficient matrix does not have an inverse, does that mean the system has no solution? No. If the coefficient matrix is not invertible, the system could be inconsistent and have no solution, or it can be dependent and have infinitely many solutions. Now, for example number 7, we're going to solve a 2x2 system using the inverse of a matrix. So the system is 3x plus 8y equals 5, 4x plus 11y equals 7. So in step 1, we're going to write the system in terms of a coefficient matrix, a variable matrix, and a constant matrix. So A represents the coefficient matrix, which is 3a, 4, 11, the variable matrix X, which is xy, and then B is going to equal 5, 7, which is the constant matrix. Then we can write it out in this form. 3, 8, 4, 11 times the matrix xy, which is equal to the matrix 5, 7. Now first, what we need to do is we need to find out what is the inverse of this matrix on the left. So by doing so, to quickly find the inverse, we can use the formula to calculate the inverse of a 2x2 matrix. So we're going to have the following. A inverse is equal to 1 over AD minus BC, where we have times D, negative B, negative C, and A. So we know that A up here is going to equal 3. And we know that, A is going to equal 3. We know that B is equal to 8. We know that C is equal to 4. And we know that D is equal to 11. So let's plug it into the formula so that we can figure that out. So we have 1 over 3 times 11 minus 8 times 4 times 11, negative 8, negative 4, and 3. So 1 over 3 times 11, which is 33, minus 32 is 1. So that's 1 over 1. And then the inverse matrix is going to look like the following. 11, negative 8, negative 4, and 3. Okay, now we're ready to solve. So we're going to multiply both sides of the equation by A inverse. So if we multiply A inverse times that matrix, it's going to give us the identity matrix, which means all we're going to have left is 1 times x, y. So therefore, the left side is easily then just to see that you're going to get x, y, regardless when you multiply the inverse by the matrix. On the right side, we're going to take our inverse, which is 11, negative 8, negative 4, and 3, and we're going to multiply it by the constant matrix B, which is 5, 7. So we have 11 times 5 plus negative 8 times 7. We have negative 4 times 5 plus 3 times 7. Well, 11 times 5 is 55 plus negative 56 gives us negative 1. Negative 4 times 5 is negative 20 plus 21 gives you positive 1. And so from here, we can see that x is going to equal negative 1. And we know that y is going to equal positive 1, which then tells us what the solution is. And the solution is negative 1, 1. Now, last thing here, it says, can we solve for x by finding the product of b times a times inverse? Well, no. Recall that the matrix multiplication is not commutative. So you can't say that a inverse b equals b times a inverse. So consider our steps for solving the matrix equation. Okay, on this side we get A inverse times A, which makes us the identity. A inverse times B, we have to make sure that we multiply it on the left side. So notice in the first step we multiply both sides of the equation by A inverse, but the A inverse was to the left of A on the left side and to the left of B on the right side, because matrix multiplication is not commutative and order does matter, so you want to pay close attention to that.